Okay, let's dive in. Time travel. It's one of those concepts, is an absolute bedrock of sci-fi.
Oh, definitely.
Mm.
For generations.
But you always wonder, like, is there anything real behind it? Beyond the movies, I mean.
Right.
So, for our deep dive today, we're kicking off with this really weird story. March 2003. Apparently, the FBI arrested this guy, Andrew Carlson, 44 years old.
I think I remember hearing about this one. The stock market guy.
That's the one. He apparently turned like 800 into $350 million.
In 2 weeks.
2 weeks. I mean, come on. That's not just lucky, is it?
Not even close. And the really wild part wasn't just the money, it was his explanation.
Yeah.
When they questioned him, he just straight up said he was a time traveler.
From when?
From the year 2256.
Yeah.
Said he just, knew how the market was going to perform.
Wow. Okay. That's audacious is one word for it.
Uh-huh. And obviously, everyone suspected insider trading, right? Makes way more sense.
Of course. But the story gets even stranger. They apparently couldn't find any record of this Andrew Carlson, like none before December 2002.
Mm-hmm.
And then, this is the kicker, he supposedly vanished, just disappeared before his bail hearing in April.
Vanished. Seriously.
Vanished. It's just,
Yeah.
It feels like something out of a movie script blurring that line between, fact and fiction.
Absolutely.
So this story, I mean, it's probably fabricated, let's be honest, but it plants that seed, doesn't it? Is time travel just stories, or is there actually room for it in how we understand the universe?
And that's really the big question we're digging into.
Yeah, that's the core.
So to try and get a handle on it, we looked at a couple perspectives. There's a great video from Dhruv Rathee looking at the physics, the theories around moving through time.
Okay.
And another one from Chris Kazakt in a nutshell, which sort of tackles the nature of time itself, as a dimension, and how Einstein really flipped our understanding of it.
Right, Einstein. So let's maybe start with what seems possible, or at least more accepted scientifically, traveling to the future.
Yes.
Yeah.
Both sources definitely cover this. And the consensus seems to be, well, it's not just possible, it's something that actually happens.
Happens already.
Yeah, constantly. Just usually in incredibly tiny amounts that we don't notice.
Okay, how?
It comes down to Albert Einstein again. His theory of special relativity and this thing called time dilation.
Not dilation, okay.
So before Einstein, everyone basically followed Newton. Time was absolute. Click, click, click. Same for everyone, everywhere.
Like a universal clock.
Exactly.
Yeah.
But Einstein showed, nope, time is relative.
Yeah.
It can actually stretch or compress. It depends on how fast you're moving compared to someone else, and also on gravity.
Whoa, so it's not fixed, it's fluid, and the two big things influencing it are speed and gravity.
You got it. Speed and gravity. With speed, it's pretty straightforward, conceptually at least. The faster you move through space relative to someone just sitting still, the slower time passes for you. Slower. Now, we're talking really fast speeds here, like speeds getting close to the speed of light for the effect to be really noticeable.
No, it's a real effect.
Oh, yeah. Proven. The Dhruv Rathee source mentions the Hafele-Keating experiment back in '71. They flew atomic clocks on commercial jets around the world.
Atomic clocks, like super precise ones.
Extremely precise. And when they compared them to identical clocks left on the ground, the ones that flew were slightly behind. Just a tiny bit, but measurably behind.
Wow. So that proves it. Time literally ran slower for the clocks on the plane because they were moving faster.
Precisely. A real-world confirmation of time dilation from speed, even at, airplane speeds, which are nothing compared to light speed.
So technically, every time we fly, we're traveling like a tiny, tiny fraction of a second into the future compared to people on the ground.
Technically, yes. Exactly. And the effect gets much, much bigger the closer you get to the speed of light.
So hypothetically,
Yeah. If you took off in a spaceship, went really, really fast, say a big fraction of light speed for maybe 5 years, your time.
okay, 5 years on the ship clock.
Right. When you came back to Earth, centuries could have gone by.
Centuries.
Potentially. So, in a way, we're all constantly time traveling into the future. It's just that our everyday speeds make the differences totally minuscule.
Okay, what about that cosmonaut, Gennady Padalka? The sources mention him having traveled the most into the future. How does that work?
Ah, right. Well, he spent the most total time in space orbiting Earth. Something like 879 days altogether.
Wow.
And the International Space Station, where he spent a lot of that time, orbits really fast. So because of that high speed over such a long cumulative period, he experienced time dilation.
Noticeably.
Well, noticeably in a scientific sense.
Yeah.
Calculations show he experienced about 0.02 seconds less time than he would have if you'd stayed on Earth.
0.02 seconds.
Yeah. So it sounds tiny, but it's real. He has effectively traveled 0.02 seconds further into our future than we have.
Okay, that's speed. What about gravity? How does gravity mess with time?
So that's Einstein's general relativity. It tells us gravity isn't just a force pulling things together. It's actually a curve or a warp in the fabric of space-time itself.
Space-time, like time and space are linked.
Exactly, linked together. And massive objects, or large amounts of energy, cause this fabric to curve. The stronger the gravity, the more massive the object, the more space-time curves, and the slower time passes within that curve.
Slower time near massive objects.
Yep. Think of like a heavy bowling ball on a stretched rubber sheet. It makes a dip, right?
Yeah.
Anything rolling near that dip follows the curve. It's similar with space-time. Time flows slower in those deeper gravity wells.
So to really see a big difference, you'd need, like, a black hole. Something incredibly massive.
Precisely. Like in the movie Interstellar. Remember the planet near the black hole?
Oh, yeah, where 1 hour for them was years back on Earth.
Exactly. Now, the movie took liberties, of course, it's fiction, but the basic principle, intense gravity slowing down time, that's real physics based on general relativity. It's been measured.
Measured? How?
Well, even here on Earth, clocks run slightly faster at higher altitudes, where gravity is marginally weaker. It's tiny, but measurable with atomic clocks.
It's just wild that these aren't just abstract ideas. You mentioned they have practical uses, like GPS.
Yeah. Oh, absolutely crucial for GPS.
Yeah.
The satellites are orbiting way up high, moving fast, and they're in weaker gravity than we are down here.
Ah, so both effects are happening, speed and gravity.
Both. The speed makes their clocks tick slightly slower, but the weaker gravity makes their clocks tick slightly faster. Engineers have to calculate and constantly correct for both of these relativistic effects combined.
And if they didn't?
The whole GPS system would fail. Your position would drift off by miles within, like, a day. It relies entirely on accounting for time dilation.
Okay, so future travel seems legit, scientifically speaking, even happening now in tiny ways.
Relatively solid ground, yeah.
But going the other way, backwards, that's the tricky one, right? That's where you get the real head scratchers.
Indeed. That's where things get much, much more complicated, theoretically and logically.
Because the physics doesn't completely rule it out.
Well, some interpretations of general relativity allow for theoretical possibilities, like paths called closed time-like curves. Think of them as loops in space-time that could potentially lead back to the past.
Loops in time.
Yeah. But, and this is a huge but, they immediately throw up massive logical problems, the big one being paradoxes.
Right, the paradoxes, like the classic one, everyone knows the grandfather paradox.
Exactly that one. It perfectly illustrates the problem with causality. You know, the idea that cause must come before effect.
So the paradox is, if you go back in time and say, prevent your grandfather from ever meeting your grandmother.
And then you would never have been born.
Right, but if you were never born...
How did you travel back in time in the first place to stop them?
Ugh, it's a loop you can't escape. It contradicts itself.
Precisely. A logical impossibility within a single consistent timeline.
It really does make your head spin. I think our sources mention some ways physicists have tried to think around these paradoxes, like multiple universes.
Yeah, the multiverse or many worlds interpretation is one way some physicists try to resolve it. The idea is, if you go back and change something crucial, like stopping your grandparents' meeting...
You don't actually change your past.
No. Instead, your action supposedly splits off a whole new reality. A parallel universe is created where that change happens.
So in your original timeline, you were born, you traveled back, but the change you made only affected this new timeline you branched off.
That's the idea. It preserves causality in your original universe, at least. You still exist there. But it means creating countless new universes with every potential change.
Which is, well, a pretty mind-bending idea itself.
To say the least.
Okay, what about the other one? The predestination paradox. How does that work?
Predestination is different. It suggests the past is fixed. It's self-consistent. Any attempt you make to change the past was always part of the past.
So you can't actually change anything because your actions were meant to happen.
Exactly. The classic example our source mentions is, say, you go back in time specifically to prevent some big disaster you know about.
Okay.
But your actions, the very things you do trying to stop it, actually end up inadvertently causing the disaster in the first place.
Whoa. So you were destined to cause it all along, even when trying to prevent it.
In that view, yes. The timeline sort of protects itself. Your trip to the past was always part of the sequence of events leading to the outcome you already knew. No
Yeah.
paradox, because nothing actually changed from how it was supposed to be.
It's like the universe course corrects, or rather had already accounted for your interference.
Something like that, yeah. Ensures consistency.
Okay, there was also a mention, I think, in the Kurzgesagt source about maybe faster than light travel. Could that allow travel to the past?
Ah, yes. Tashians. So, Einstein's special relativity is famous for saying nothing with mass can reach or exceed the speed of light.
Right, the ultimate speed limit.
Pretty much. But the theory doesn't strictly forbid the existence of hypothetical particles that always travel faster than light. These are called tachyons.
Hypothetical, though.
Entirely hypothetical. And theoretically, if they existed and if we could somehow interact with them, their faster than light movement could be interpreted, mathematically at least, as moving backward in time.
That's a lot of ifs.
Huge ifs. We have absolutely zero evidence that tachyons exist. None. And no idea how we'd even detect or use them if they did.
So, faster than light travel to the past is pure speculation at this point.
Firmly in the realm of speculation, yes. Not supported by any current physics or observation.
Okay, so summing up the past travel idea, it seems the science is heavily against it, mainly because of the paradoxes and just no known way to actually do it.
That seems to be the current consensus. The
Yeah.
logical hurdles, the causality problems, they're just immense. And we lack any known physical mechanism.
Right, which brings us back full circle, sort of, to Andrew Carlssin, the time-traveling stock trader. Our dhruv rathee source actually had some interesting info on where that story came from, didn't it?
Yes, that was quite revealing. It turns out the whole Andrew Carlson story originated in a newspaper called the Weekly World News.
Oh, isn't that like a satirical tabloid? The kind with headlines about aliens and Elvis sighting?
Exactly. It was known for publishing completely fictional, often outlandish stories presented as news. Pure satire.
So the Carlson story was just made up for fun.
Almost certainly.
Yeah.
But somehow, maybe because it was such a cool story, it got picked up by other outlets. Sometimes they didn't mention the source or maybe didn't realize it was satire.
And it just spread. People started thinking it might be real.
It seems so. It became this kind of urban legend, a viral story, before we really called things viral.
Wow. So the amazing time traveler from 2256 was likely just a clever bit of fiction from a tabloid.
In all probability, yes. But, it definitely did its job, sparking interest and questions about time travel.
It sure did. It highlights how much we're fascinated by the idea, doesn't it?
Absolutely. And look, while going back to the past seems blocked by these major theoretical walls,
Yeah.
our chat confirms that traveling forward into the future using time dilation, that's real science. It's embedded in relativity.
Even if we can't yet build spaceships to make centuries pass for us.
Right, our tech limits how much we can use it for big jumps.
Yeah.
But the principle is sound. And, we also touched briefly on things like cryosleep.
Ah, yeah. Freezing people to wake up later.
Well, or drastically slowing metabolism. That's another sort of speculative way one might travel to the distant future by skipping the intervening time biologically. More sci-fi for now, but conceptually different from time dilation.
Okay, so let's try and wrap this deep dive up. The takeaway seems to be journeying to the future, scientifically possible. It's grounded in Einstein's theories, time dilation from speed and gravity, stuff we actually measure and use, like in GPS.
And maybe one day, other tech like advanced cryosleep could offer a different route.
But going back to the past, that's still a huge maybe, probably closer to a no, right?
Right.
It's tangled up in paradoxes, causality loops.
Yeah, a theoretical minefield.
Yeah.
Seems impossible with our current understanding. So stories like Andrew Carlson's, however fun, are almost certainly just stories.
Got it.
Which leaves us with a final thought, maybe for our listener to chew on.
Okay.
We know we're all moving into the future 1 second at a time.
Right.
But knowing that time itself isn't fixed, that it's flexible, influenced by speed and gravity, how does that understanding that time can be dilated maybe subtly change how we think about the present moment? And the choices we make right now as we travel into our own personal futures, does knowing time is relative affect how we value our time?
That's definitely some interesting food for thought. Makes you think about the now a bit differently.
Right.
All right, well, on that note, I think that's us for this deep dive.
Indeed.
Okay, bye-bye, everyone.
Bye-bye.